All right, so I'm going to go over Got It C, D, and E for your homework today. Got It C says in example 3, what is the experimental probability of rolling the sum that is not 9? Well, up above in example 3, we found that the experimental probability of rolling a 9 is 8 out of 20, which we reduced to 2 over 5. Okay? Now, this problem is a complementary because it's the opposite of rolling a 9, and that's not rolling a 9. So if we actually rolled 9 8 out of 20 times, we didn't roll 9. 20 minus 8, 11 times. So our fraction would be 11 out of 20. That cannot be reduced. But we can write it as a decimal fraction in percent. So we would take 11 divided by 20 and get 55 hundredths, which is the same as 55%. Okay, so the answer for Got It C is 55%, 55 hundredths, and 11 20ths. Got It D says 2 coins are tossed 10 times. Both coins land on heads 6 times. Compare the experimental probability to the theoretical probability. If the pair of probabilities are not close, explain a possible reason for discrepancy. Okay, so we have 2 coins and they land on them 6 out of 10 times. It doesn't really matter that there's 2 coins because you still only have the same option. So 6 out of the 10 times were landed on heads. If we reduce this, we could reduce it by 2. And we would get an answer of 3/5. 3/5 as a decimal is 6/10, which is the same as 60%. So again, that is our theoretical. Or no, sorry, that is our experimental, because it's what we actually did. Now, if we're talking about our experimental, we only have 1 out of 2 options that are heads. So this as a decimal is 5/10, which is the same as 50%. Okay, our question asks us to compare them. So we would say that our experimental is greater than theoretical, because 60% is greater than 50%. Okay? It also asks us to explain a possible reason for the discrepancy. Well, we only flipped our coin 10 times. Remember, the more times that we conduct an experiment, the closer and closer you get to theoretical. We're even not that far off, but still we're a little off by 10%. Okay, so then Got It E says, suppose all 3 coins are tossed 10 times. All 3 coins land on heads 1 time. Compare the experimental probability to the theoretical. So this time we landed on heads 1 out of the 10 times. Again, it doesn't really matter that we have 3 coins. Okay, this as a decimal is 1/10, and it would be 10%. The theoretical probability, again, we only have 1 out of 2 options that are heads. So this would be the same as 5/10 or 50%. Okay. It says to explain a possible reason for the discrepancy. Oh, it says to compare them, sorry, first. So we would say that our experimental, so this is Got It E, our experimental is less than theoretical because 10% is less than 50%. Okay, then to explain the possible reason for discrepancy, 1, we only conducted it the experiment 10 times. Another reason is because you have less of a chance of landing on heads on the same toss with all 3 coins. Okay, because the number of coins you increase, the fewer and fewer chances you're going to have that all 3 are going to be the exact same. I'm also going to go ahead and work on the next page and show you number 1 and 2. So it says a number cube is rolled 20 times and lands on 1 2 times and on 5 4 times. Find the experimental probability, then compare the experimental to the theoretical. Okay, so if we were doing experimental, we would say that we landed on 5 4 out of our 20 times, which is reduced to 1/5, which is the same as 2/10, which is the same as 20%. Okay, our theoretical probability is, on a dice, you have 6 options, 1, 2, 3, 4, 5, and 6. Only one of those options is 5, so you have 1 out of the 6. That can't be reduced, but as a decimal, it is 0 and 1700ths, which is the same as 17%. Okay, our question asks us to compare them. So now that I figured them out, I would say experimental is greater than theoretical because 20% is greater than 17%. Now, our questions were really close, and that was because we rolled a number of 20 times in our experiment. Got it. B says not landing on 1. Okay, so in our experiment, it says that we landed on 1 2 times. So if we landed on 1 2 times, we didn't land on 1 18 times. So then we would have 18 over 20, which can be reduced by 2. And we would get 9 over 10, which is the same as 9/10, which is the same as 90%. If we were conducting our theoretical probability, we still have our 6 options on a dice, but 1, 2, 3, 4, 5 of them are not 1, so we would have 5 out of 6. This would be written as a decimal as 8300ths, which is the same as 83%. To compare them, we would say that experimental is greater than theoretical, and that's because 90% is greater than 83%, but again, these are really close to each other. Number 2, so the spinner at the right is spun 12 times, and it lands on blue 1 time. What is the experimental probability of the spinner landing on blue? So it actually landed on blue 1 out of 12, which is the same as 800ths, which is the same as 8%. B says compare the experimental and theoretical probabilities of the spinner landing on blue. If the probabilities are not close, explain a possible reason for discrepancy. Okay, so if I look at my spinner, I have 1 out of the 4 options that are blue, which is the same as 2500ths, which is the same as 25%. Okay, when we compare them, we would say that our experimental is less than our theoretical, and that's because is less than 25%. And a reason why is because we only spun the spunner 12 times, and the more times that we do it, the closer and closer we will get to theoretical probability.